Okay, so in this video we're going to talk about residual plots, which shouldn't be too complicated, and then we're going to talk about, mainly we're going to talk about S and R squared, which we'll get into eventually. So if you haven't printed out your PowerPoints, please do so. There, chapter 3.2 is uploaded. So on residual plots. One of the first principles of data analysis, look for an overall pattern for striking departures from the pattern. Hold on a second.
Farinelli and Josh Williams for counseling office, please. Farinelli and Josh Williams, counseling office, please.
Okay. A regression line describes the overall pattern of a linear relationships. We see departures from this pattern by looking at the residuals. So a residual plot, which is actually not this one. This is your residual plot. And you can tell it is your residual plot because your y-axis is going to say residual on it. Okay, this is your scatter plot with your least squares regression line. This is your residual plot. Now, how to get from this one to this one is they've done the following. So they've said, okay, well, if you look really closely on this one right here, I have to fix the zoom really quickly. If you look really closely on this one, you can see that each one is a certain distance away from your actual regression line, right? So this one's this far away, this is this far away, that far away, that far away, that far away. So what they've done is they've taken the distances of how far away the data is from your regression line and they've just plotted it. So this might be like a distance of 1, right? Or something like that. So they've done, well, this plot, this point right here is going to be 1 above your, regression line. This one right here, maybe it's a distance of, negative, whatever it might be. Or actually the distance is positive, but it's going to be below the regression line by, 10,000, somewhere around there. Okay, so it's going to be, it's at negative 5,000. So there's a difference of 5,000. And then you just plot it down there. That's all it is. Now, on the calculator, I'm going to show you how to do this in class right now. This is just going to take too long. But suffice to say, this is your scatter plot, all right? And then this is your residual plot. So basically just taking the actual minus your predicted and plotting every single one of the points in, and you get something that looks like that. The reason that we want to do this is in the next slide. When you have a residual plot, okay, that actually manages to have a pattern to it, that means we do not want to use a line to plot to make a prediction on what the scatter plot is doing. So if this is your scatter plot and you use the line, the way that you know a line is appropriate to use for your data points is if your residual plot does not have an overall pattern. If it does, like this slide here or the next slide here, that means using a linear model is not appropriate. Okay, so I'll say it again. If you have an overall pattern in your residuals, then using a linear model is not appropriate. You usually want your residual plot to look like this, and that's when you know, okay, a linear regression line should probably fit my data pretty well. All right, that's why we want to know if the residual plot comes out nicely. Okay, and the next slides. Okay, standard deviation we're going to talk about in a second, and coefficient of determination. This is all just information. When we get to it, interpretation of these two is really what you want to get down, not so much memorizing the formula. So standard deviation, to assess how well the line fits all the data, so how well, right, the line fits the data, we need to consider the residuals for each observation, which we do, not just one. Using these residuals, we can estimate the typical prediction error when using the least squares regression line. So how far off is your typical residual going to be? Are you usually off base, like a 1.5, or are you off by 1 or 0.5, or are you off by 2 most of the time? What's a typical prediction error? Okay, and that is what we call the standard deviation of the residuals, or S. And I'm going to show you on the calculator how to find S, and then I'll remind you in class again in a second. Okay, and then give me just a second because I wanted to get to the coefficient of determination, because that's your R squared. We didn't really talk about R in this class. Well, we did in correlation, so I'll show you what it looks like in just a second. Where is your... Okay, there it is. Okay, coefficient of determination. Remember when we were doing all those correlations, and we said, okay, well, if the data is, you know, positive association, and you have a bunch of clusters, and it looks pretty decent, you know, we have a data that looks like this, so then we can kind of estimate that R is going to be something like, I don't know, let's say 90, for example, right? Okay, well, the coefficient of the determination, R squared, is just literally taking your correlation and squaring it. So then R squared would just be 0.90 squared. So R squared in this case is going to be 81, right? So that's it. That's your coefficient of determination. That's how you find it mathematically. What you interpret it as is going to be just a little bit different. Okay? But the suffices to say, this is how you find it mathematically. If you know you have a positive association, let's say R is around 0.9, I'm just making something up. R squared is just squaring your correlation, and you have 0.81. Now, R squared, okay, and this is your determination, this is your interpretation, okay, tells us how much better the least squares regression line does at predicting values of y than simply by guessing the mean y for each value at the data set. Okay, and I'm going to do one example in the next one so you can see exactly what it is that you're supposed to write down. Okay, so how much better is the least squares regression line at predicting the values than just guessing what it might be? All right, so standard deviations tells us the typical prediction error for residuals. You know, how off are we typically on a prediction error? And then R squared gives you how much better is the least squares regression line at predicting values. All right, those are the two. So we're going to do the next example. It kind of combines everything we've done in the last two videos plus what we just did. We have in section 3.1, we looked at a relationship between average number of points scored per game, X. All right, and then the number of wins, Y, for 12 college football teams. Southeastern Conference, a scatter plot with the least squares regression line. This is your scatter plot. There's your regression line. Okay, and then the residual plot is here. Okay, so right away looking at this, I'm pretty sure a linear model is a good fit because there's no overall pattern in the residuals. So we're good to go on the regression line. Okay, so they gave us an equation for y hat, negative 3.75 plus 0.43x. Our standard deviation for the residuals is 1.24. All right, and then our R squared, or coefficient of determination, is going to be 0.88. Okay, here we go. We have, for the first one, calculate and interpret the residual for South Carolina, which scored 30.1 points per game and had 11 wins. So this is going to be a twofold step process. First, we have to find what was the predicted amount. And then once we find the predicted amount, we can calculate residual by doing the actual minus the predicted amount, or the observation value minus the predicted amount, and find the residual. All right, so the first thing is we're going to need our equation, which was negative 3.75 plus 0.437x. Okay, so points per game and had 11 wins. So it tells us here that points scored per game is your x value, and the number of wins is going to be your y value. All right, well, we want to find the y predicted, so I'm not going to plug in a number of wins, I'm going to plug in points per game because that's going to be on my x-axis. And that's going to be my explanatory variable. So we have negative 3.75. Why did I say negative? Oh, yeah. Plus 0.437 multiplied by 30.1. And that should give us a y hat of, let's see, negative 3.75 plus 0.437 multiplied by 30.1 gives us a predicted value of 9.4. 9.4. Yeah, I'm just going to leave it there. So that means we have around a predicted value of 9.4 wins if we were supposed to get, so predicted, if you had scored 30.1 points per game, you were supposed to have around 9.4 wins. Now, I don't know about not having exactly 9.4 wins. That doesn't make a lot of sense to me. So, I don't know. You can kind of estimate it. You're going to have at least, 9 wins. All right. Okay. So, 9.4, round 9 wins. You can't have 4 of a win. That doesn't make any sense. Okay, so that's step 1. Step 2, now calculate the residual. So we have our observation value minus our predicted. And our residual is going to be, so observation is going to be 11 minus your predicted, well, let's say 9, right? So your residual should be around, what is 9, 11 minus 9? Oh my God, I'm so tired. 10, 11, 2. Okay. So as a final answer, we have, well, I guess they did 9.4. I don't really know. I don't like 9.4. But if you really want 9.4, you can do 9.4, and then you get 1.6. So I guess you can decide which one you want to pick. But this doesn't make any sense to me to have 0.4 of a win. So, South Carolina 1, 2